Hello, welcome to today's edition of Mix Academy. We are looking at lesson 18.1, volume of prisms and cylinders. So we're going to just start right out with the volume of a right rectangular prism. And the reason it's called right is because the base creates a right angle with the height. So for the right rectangular prism, volume is length times width times height. You may remember this from middle school. Now, the textbook will use the capital B for the area of the base, which is then length times width. And there's a diagram of what that would look like. Just so you know, though, also a cube is also a right rectangular prism. All right, so we are going to find the volume of a right rectangular prism that has a width of 6 inches, length of 12, and a height of 8. So first thing, identify length, width, and height. Length 12, width 8. Sorry, width is 6, height is 8. And then plug that into the formula. 12 times 6 times 8, which type that into trusty calculator, is 576 inches cubed. Okay, make sure you're answering in cubic units. The next thing we will look at is the volume of a right cylinder. Okay, again, right because the base creates a right angle with the height. And for a cylinder, the bases are circles. Think of a soda can, for example, or a Pringles can. Also here, capital B again, area of the base, which the area of a circle is pi r squared. We did that last week. All right, so we're going to find the volume of a right cylinder whose base has a radius of 3 and is 7 feet high. So identify radius and the height. 3 feet for radius, 7 feet for height. Plug it into the formula and evaluate that. 3 squared is 9. 9 times 7 is 63 pi. And then when we multiply it out using the pi button on the calculator, we get approximately 197.9 feet cubed. Again, volume is always cubic units. All right, we're going to look at also a right triangular prism with the bases this time being triangles. That's why it's triangular, but they are right triangles. Okay, and note that the length and the width are the legs of the right triangle. The formula is 1/2 length times width times height because it is 1/2 of a rectangular prism. Just like a rectangle is half of a triangle is half of a rectangle. So find the volume of the prism whose legs are both 4 centimeters and whose height is 10. So again, we need to identify length, width, and height. Length and width are the same because the legs are the same. Those are both 4. Height is 10. Plug that into your formula and make sure that we label cubic units. 1/2 of 4 times 4 times 10. And trusty calculator says that is 80 cubic centimeters. We're going to talk next about oblique prisms. Oblique means slanted or tilted over. So think about the broken bookcase that's leaning over, or the Leaning Tower of Pisa, okay? what these oblique prisms have are called slant heights. That is that diagonal, that leaning over part. But to find volume, we need perpendicular height, which is the height from the top to the bottom, creating a 90-degree angle, okay? Which creates a right triangle. So slant height and perpendicular height, distance apart from them, create a right triangle. So you can use Pythagorean theorem to find the perpendicular height if you need to. All right. And the formula for the volume of an oblique prism is length times width times perpendicular height. So be very careful about that. So find the volume of an oblique prism with a width of 9 centimeters, a length of 4, and a height of 6. Again, make sure we've got perpendicular height, and then we're going to identify length, width, and perpendicular height. Length is 4, width is 9, perpendicular height is 6. Plug it in, 4 times 9 times 6. Type it out, 216 centimeters cubed. Okay, again, cubic centimeters. All right, last thing we're going to look at is the oblique cylinders. Okay, cylinder again has the circle for the bases. And we need to find perpendicular height if needed. Now, slant height earlier I had as an S. It is also this lowercase cursive L. So you'll see both of those in the textbook, the lowercase s or a lowercase cursive L. That means slant height. So be very careful when you're identifying those. Okay, so they give us a volume of an oblique cylinder that has a base diameter of 14 and a slant height of 7 meters. So the picture I drew here sort of gives you that. We have the slant height is 17. Diameter of the circle is 14, and we need to find that height. So we're going to use Pythagorean theorem, and I drew a little sketch just to help us out a little bit. Okay, the diameter 14, the slant height 17, we need to find perpendicular height. So a squared plus b squared equals c squared. Hypotenuse is always c. So we have 17 squared equals 14 squared plus b squared. And again, typing in the trusty calculator. 17 squared is 289. 14 squared is 196 plus b squared. Subtract 196 from both sides. So 289 minus 196 gives us 93. Okay, but remember that is b squared is 93. And to undo squaring, we square root. So square root of b squared equals the square root of 93, which is about, and I'm rounding off here, 9.644. So we know our B here, remember, was our perpendicular height. So now we know our perpendicular height, and we need to identify the radius. Radius, remember, is half of the diameter. If the diameter is 14, half of that we know is 7. Perpendicular height, 9.644 approximately. Plug that into our formula. So radius 7 squared times 9.644 Type that all in again to the calculator. 472.556 pi. And then again, use your pi button. It is more precise. And round off to the nearest tenth. So 1,484.6 cubic meters, or meters cubed. One thing I want to touch on before we conclude today is composite figures. We've talked about those before, and that's when you put two different figures together. Now, when you're finding the volume of composite figures, first, find the volume of each figure. If you're adding volumes, add the volumes if they are two figures put together. Notice this house solid would be a rectangular prism with a triangular prism. So you find the volume of each of those and add them together. Let's say this here would be a thick pipe. You find the volume of the large cylinder, find the volume of the smaller cylinder, and then subtract it because this figure shows that there's a hole down the middle. So that you subtract those two to find the volume of that outer edge. All right, don't forget, email me if you have any questions, and I will see you soon. Have a great day.